Hello dear friends, we are continuing with organic photochemistry. So far we have discussed different topics in organic photochemistry which are very important topics. That is what happens to an organic molecule once it absorbs energy from the UV visible radiation, and what are the different excited state in that molecule is going, and what is the different excited states for an electron to go into the higher levels. We also have discussed about the selection rules and Frank-Condon principle and symmetry rules regarding the allowed transitions and forbidden transitions, and influence of the solvent on the position of the absorption band also we have discussed. So afterwards we are going to discuss today a new topic, that is chemistry of an excited molecule. Chemistry of an excited molecule. What happens to an organic molecule once it is absorbing energy and getting into an excited state? As we have mentioned, as I have mentioned to you earlier, that is an excited singlet state or excited triplet state only will undergo chemical reactions to give a product. Okay, so the excited singlet or triplet state will either undergo chemical reactions or a photochemical reaction, or lose their energy and come back to the ground level. Okay, so by a radiative or a non-radiative process. Suppose if a molecule M absorbs energy and goes into the singlet state or a triplet state. Okay, from these two states only the molecule is undergoing a photochemical reaction to give into a product. So here what happens when it to convert into product, there can be different processes. Okay, either a radiative process or a non-radiative process. The molecule in their excited state can lose energy, okay, by intramolecular energy transfer. Okay, so suppose a molecule absorbs energy and gets into an excited state, and excited state molecule only will undergo different type of a photochemical reactions to give into product. Now what happens in this excited state only? We have spoke about the singlet state and triplet state. Okay, now the molecules in their excited state can also lose their energy by an intermolecular energy transfer. So what happens this intermolecular energy transfer? In organic molecules, almost all organic molecules in the ground state are singlet state. Okay, they are singlet state. I have told to you that means they are spin paired. They are spin paired. The first excited state on absorption of light is usually singlet state. When a molecule absorbs energy, from an invisible region, it is going into an excited state, that is usually a singlet state where the spin pairing is taking place. Okay, it has already, so what happens, that is S0. Okay, S0 to the molecule is going to S1 level. Okay, now we also have seen that it has already been stated that promotion from S0 to the molecule can never go from directly S0 to triplet state. That is transition is a forbidden transition. So what happened? S1, the molecule in the excited state having a very short life and excess energy can undergo different changes to give into a product. Okay, so I am going to explain to you once more. We have seen that the molecule after absorbing energy, it is going into an excited state, and the chemical reactions or a photochemical reaction where this excited molecule undergoes will give us a product. Now, this excited state means when a molecule absorbs energy, that from ground level to it is going to the S1, that means a singlet excited state. Singlet means that spin is paired. Okay, the molecule or an excitation can never take place from S0 to directly a triplet state, that is a spin forbidden transition. Now, since the molecule has a very short life at singlet excited state, that energy can be dissipated into different types, one or more different processes. It has to come back to the ground state to give to the product. And we also have known that S1, then only if S0, then this is S1 level and T1 level is somewhere in between. So the molecule can go from S0 to S1, but the molecule can never go S1 to T1, S0 to T1 state. That means the molecule here can undergo different changes. Either it can emit radiation or energy and come back to the zero ground level, or it can come to a triplet state. The molecule in the excited singlet state only can come into a triplet state. Okay, so now we will see what are the different changes that are taking place for an excited molecule. So the changes that are taking place for a molecule in this excited state. Okay, the first one is the singlet excited state. Okay, that is S0 after ground state, after absorbing energy. It is going to be a singlet excited state. Can come back to a ground state. Can come back to a ground state by emission of a light or a photon. This process is called fluorescence. This process is called fluorescence. Okay, that means the molecule after absorbing energy is going to a singlet excited state. Now here it is that molecule is having very short life. That means the lifetime here is only 10 raised to minus 8 to 10 raised to minus 7. So it has to come back to the ground state by emitting energy. That process of coming back from excited singlet state to a ground state is called fluorescence. Okay, the fluorescent light has a longer wavelength than the light required for the original excitation. The light which is released from S1 to S0, that means singlet excited state to the ground state, when the light is emitted, that light wavelength is very higher than the light wavelength that is required from a ground state to an excited state. So the fluorescent light has a longer wavelength. It has a longer wavelength. Okay, then the energy required for a molecule to absorb energy and get into the singlet excited state. Okay, then one way is it is emitting the energy and coming back. Second process can be it may return to a ground state. By a non-radiative process. That means it is not emitting energy. Non-radiative process in which the excess of energy in the excited state is supplied. What happens is the energy in the excited state can give or can rise, can create some vibrational modes in a molecule. Then the third thing is the S1 can undergo some kind of a chemical changes. That means the molecule in the singlet excited state can undergo some chemical reaction. Okay, chemical reactions. Now this is what is happening. Now fourth point is sometimes I have mentioned to you this is an ground state and it is an excited state, singlet state, and in between only triplet state is coming. Sometime it's decay to triplet state. The molecule which is present M here can come back to the triplet state. Okay, may occur before the although the conversion from S1 to T, that means a singlet excited state to the triplet state is energetically gainful. It is a slow process. It is a very slow process, and in accordance with all the spectroscopic rules, change in multiplicity is a forbidden process. Okay, however, if the singlet state is sufficiently long-lived, if the singlet state is sufficiently long-lived in an aromatic carbonyl compounds, the molecule from S1 to T1, the molecule from, that means singleted excited state to the triplet state is called intersystem crossing. It is called intersystem crossing. Intersystem crossing. So the fourth one can be an intersystem crossing. Okay, then the fifth one is intersystem crossing is extremely important phenomenon because it is very important. There only the chemical reaction, the product, the molecule is undergoing photochemical reactions and turned into a product. Okay, as phenomenon in photochemistry, as triplet excited state exists for much longer period. The lifetime for a molecule at the triplet state is very high. Okay, it is almost 10 raised to minus 3 to 15 seconds. 15. Okay, then a singlet state. Therefore, the photochemical reaction always favors the singlet excited state to the triplet state. Okay. Intersystem crossing is more efficient in the molecules where the energy gap between singlet excited state to the triplet state is smaller. Okay, so these type of reactions are most probably in the benzophenol case only this intersystem crossing is taking place. Now another change can be a molecule in an excited singlet state can undergo chemical transformations such as decomposition or isomerization or other chemical reactions with the surrounding molecules leading to a new product. Okay, that also can take place. The fifth point is I have mentioned to you that triplet excited state only is giving the product, and this is very much important for a photochemical reactions. And the sixth one is sometime the S1 or the molecule in the singlet excited state can react with other molecules and gives a new product. Okay, now the singlet excited state can transfer. The singlet excited state can transfer its excess electronic energy to other molecules and may be converted into S0. Okay, that means another important point is the singlet excited state can transfer its electronic energy to neighboring molecules or to other molecules, okay, and they will be coming back to a ground state, and this process is called singlet energy transfer. Singlet energy transfer. Okay, or this is also known as the photosensitization. It is also known as the photosensitization. Okay, photosensitization, and is symbolized as singlet excited state, that is S1, and it is going to ground state. Okay, energy is accepted, then you will get a ground state molecule plus a singlet molecule. Okay, this kind of energy also is very important for a photochemical reactions. The triplet state may be converted into a singlet Okay, I have said that another important point is the triplet excited state can be converted into singlet excited state. Okay, since T1 is of lower energy. However, it may, what happens, this may either undergo chemical reaction or may return to the ground state or may return to. Once a molecule from a triplet excited state, it can go to the singlet excited state, and here lifetime is very small, then it will be coming back to the ground state by emission of a photon, by emission of photon. So this process is called phosphorescence. This process is called phosphorescence. Okay, I have mentioned to you that fluorescence means that ground state molecule, the molecule from S0 to it is excited into a singlet excited state. From there it can give back its energy in the form that process is called fluorescence. Whereas here the molecule in the phosphorescence means the triplet excited state to it is going to a singlet excited state. Since the molecule or the lifetime at singlet excited state is very small, it will be emitting its energy and coming to a ground state, and this process is called phosphorescence. Like in the case of fluorescence, the wavelength of the phosphorescent light also is longer than that of the initial excited light. Okay. T1. Okay, the molecule in the triplet excited state can also transfer its electronic spin to another molecule to become converted into a ground state molecule. This process is called a triplet energy transfer. This process is called a triplet energy transfer. Okay, so all these processes I am summing up into some equations. By remembering these equations, you can remember continuously what happens. That means suppose a ground state molecule absorbs energy H nu and go to a singlet excited state. This is called excitation. This is called excitation. Okay, I will change the color so that you will understand. Okay, now sometimes singlet excited state, okay, can have energy transfer and it will give up its energy or undergo some kind of a this thing and emits its radiation. It emits radiation. It is called vibrational relaxation. Vibrational relaxation. I have mentioned to you that it may return to the ground state or may remain there by a non-radiative process in which the excess energy of the excited state may be supplied into a vibrational modes. That is called vibrational relaxation. Or it can undergo singlet excited state, can give up its energy and come to the ground state plus energy. This process is called fluorescence. Now, singlet excited state can come to the singlet ground state by emitting energy in the form of a heat. This is called internal conversion. It is called internal conversion. Okay, or singlet excited state can be coming to a triplet state that is called intersystem crossing. Intersystem crossing. Or now the molecule at the triplet state can remain there by giving up its energy in the form of a heat. This is also called vibrational relaxation. Vibrational relaxation. Now, triplet state can come to the ground state by giving up energy in the form of a radiation that is called phosphorescence. Okay. Now triplet state. Now triplet state. Triplet state can come to the ground state by giving up energy in the form of a heat is called inter-system crossing. Inter-system crossing. Okay, these are some important steps which you need to remember. And based on these steps, dear students, please all of you go through this based on these steps only we are going to discuss about the Jablonski diagram. Okay. Another important concept in the photochemistry is Jablonski diagram.